Welcome to my channel, The Sake of Physics. In today's video, I'm going to discuss how can we multiply two vectors. So, product of two vectors is divided in two different types. One is scalar or dot product, and the other one is vector or cross product. So, one by one, I'll go through both types. So, the first one is scalar or dot product. Uh, when we multiply two vectors by the dot product, then we get a scalar quantity as an answer. A scalar product of two vectors a and b, we can write them like a dot b equals av cosine of theta, where these are two vectors and a is a and b are magnitudes of these vectors, and angle is between these two vectors. For physical interpretation of two vectors a and b, we can say that a dot b equals a projection of b on a, or a dot b equals a, which is the magnitude of a, and b cosine of theta is basically magnitude of component of b in the direction of a. So in the figure you can see that vector a is along x-axis while vector b is making an angle theta with the a, and b cosine theta is the component of b, magnitude of component of b in the direction of a. So when we multiply them, then we get ab cosine theta, or on the other side we can say that angle is between both vectors. Then we can say that a cosine theta is magnitude of component of a in the direction of b, which will become b dot a or ba cosine theta. So these are the two different ways we can write them down. So here it looks like that a dot b equals b dot a. So there is an example which is a work done by a force F. So for example, there is a box and we need to move it in this direction, and we need a force F to drag it. So for example, this is the force and this is the displacement we want to make. Both are making angle theta. So here f cosine theta is the magnitude of component of f in the direction of the displacement. So we can write down that work done is basically defined from here. We can say that the effective component of force in the direction of motion times distance moved. So for example, f cosine theta is the magnitude of our effective component of force in the direction of motion times d is the distance. So here this will become f dot d. So this work done is an example of scalar product of force and displacement. So now I would love to show the characteristics of scalar product. So scalar product is commutative. What does that mean? That a dot b equals b dot a. So either you write a b cosine theta or b a cosine theta, because they are all magnitudes and multiplying, so it doesn't matter. The order doesn't matter. The scalar product of two mutually perpendicular vectors is 0. Perpendicular mean when angle between the vectors is 90 degrees. So it means that if there are two vectors and they have angle between them 90, then cosine 90 is equal to 0. So the answer is 0. So similarly, when we talk about the unit vectors along different axes like I, J, and K. I is along x-axis, J is along y-axis, and K is along z-axis. This is the normal interpretation we use. So we can say that I dot J dot K or K dot I. So you can write the num in either way because it's commutative. So their dot product will be 0 because they are perpendicular to one another. The scalar product of two parallel vectors is equal to the product of their magnitudes. So for example, if there are two vectors and they are parallel to each other. So this is A and this is B vector, and I can write them down A, B cosine theta. Parallel mean the angle is 0 degrees. So AB cos 0 gives me AB because cosine of 0 equals to 1. So similarly, I can write down the unit vectors that I dot I, J dot J, because they are parallel to each other, they will be equal to 1. The self product of a vector A is equal to the square of its magnitude because we are multiplying a same vector with itself, so we will get A square. Scalar product of two vectors A and B in terms of their rectangular components. We know that if the vector A and B they have components in three dimensions, then we can say AXI plus AYJ plus AZK, and then taking the dot product between them will simplify it because we know that the angle between the same parallel or mutually perpendicular, we get 0 and 1. So here it will become AX BX plus AY BY plus AZ BZ. Why? Because I dot J dot K and K dot I equals 0, but I dot I, J dot J, and K dot K gives us 1. So by using the definition of a dot product, A dot B equals AB cosine theta, we can find the angle between two vectors also. So this will become A dot B over AB. So here we know the values of A dot B. So AX BX plus AY BY plus AZ BZ divided by AB. So these are the characteristics of scalar product. We will use them in the numerical problems. Thank you so much.